So, as I said before, it all starts in Revit, right? So here's a great example. We have this small office lobby, and what we want to do is we want to run a ventilation study. So let me just hide these windows real quick. And we can see here that we have some plaque diffusers in the ceiling. We have some windows. We have individuals potentially downstairs and upstairs. So we kind of have a dual occupied zone that we want to take care of and look after. And of course, we're going to run a winter design day scenario because we're in an overhead heating design, because we have these plaque diffusers. We want to understand, does the air have enough momentum, the warm air have enough momentum to make its way to the windows and down to the floor, or will the buoyant effects take over and cause it to start to rise back up? So as I mentioned before, right in the add-ins here, when you install Simulation CFD, this automatically installs into your add-ins bar is this Launch Active Model BIM connection. And so by hitting that, we can pull the model directly into Simulation CFD, and we can start to set this up. Now this one's already set up, but I'll just walk through a little bit of how that works. So it's a three-step process, very top-down workflow. Let's get straight here. There we go. You start with your materials. Next up, you set your boundary conditions, and then after that you set your mesh sizes, and then we'll solve it. So as I mentioned before, we have an AEC specific materials database. I have some of my favorites set here already. So brick, concrete, air, glass, human, hardwood, water, and aluminum. We can also go in, and we have many more materials than just those, so it's very easy to go into the material editor dialog and create your own material. If you can describe it, you can create it in Simulation CFD. And so we have different conductivities, density, specific heat, and then we have the radiative properties as well, emissivity, transmissivity, and then by default reflectivity, and even wall roughness. So here are all the default materials that ship with the simulation solution. We can see the liquids, the solids. We even have some internal fans, some server racks, some tiles, some LED lights set up by default. So try to make that part of it very very straightforward and very seamless, right? So we'll essentially go in and just right click, so we can set this to glass, this window. We can do the same thing with this one. Set that to glass using our favorites as well. If we hide that, we can see inside, and we see that Simulation CFD also automatically created an air part for you on the inside. Of course, we need that air volume in order to calculate what's happening in the space. And then we can set up our human materials, our couches, our stairs, and you can see that when you float over these, you get this instant feedback as to exactly what type of material that is. All right, so after the materials, we'll set up the boundary conditions. And the boundary conditions it's just a fancy term for the engineering quantities that we know. So we know that each of these diffusers is pushing 350 CFM. And it's as simple as just right-clicking, selecting what type of boundary condition we want to assign. So is it an air speed, a velocity? Is it a volume flow rate, a pressure, or a temperature? By far the most common for the AEC market. Most of these you probably won't need, but in case you wanted to assign humidity or film coefficients or heat fluxes, those are there as well. So we'll set up the supply diffusers, then we'll set up the return registers, so we can just right click on the air returns and give those a 0 gauge pressure. That just tells Simulation CFD where the air is going to leave the room. And then we can select the outer walls as well and assign some U values. So our term for that is film coefficient, but it's exactly the same as a U value. Then based on the time of year, the temperature outside, and maybe the wind speed, you can there are textbook tables for these U values that you can assign, and that lets it gain or lose heat from or to the environment. Okay, so our boundary conditions are done. Oh yeah, one more. We'll also set up the humans, right? We want to understand their comfort level, so we can just grab them and give them a total heat generation. In this case, we'll do 70 watts, pretty standard. And then the last step is the meshing, right? And so meshing has historically been just very difficult and very painful in a lot of the older traditional simulation tools. Within Simulation CFD, it's very different. So we're taking that native Revit geometry, which is a benefit already, because we know we're creating really solid, high integrity geometry in Revit and pulling that in. But what Simulation CFD does is it looks at two things: edge length and curvature. So anywhere we have tighter curvature or shorter edges, we have more detail, like we see around this individual. And anywhere that we have less detail or longer, straighter edges, we can see that these blue dots get farther and farther apart, which means we'll have a little bit coarser mesh. We can even just look at a quick preview on the floor here, and we can see exactly what I referenced in action. We can see that, as we get closer to the feet and we have more detail, the mesh tightens up. As we work our way away, it becomes coarser, and that's key. So the mesh is critical and it's key to a good solution, and this auto mesher takes care of about 95% of that process for you. So the last step is we'll solve it and then start to look at some results, right? So I can jump in, and the first thing that I like to do, let me switch back. I was messing around with this before. I'll switch back to our shaded mode and turn our vectors off on this cut plane. But as I said before, a cut plane is like a 2D slice through the model. So I can take this 2D slice and just kind of sweep it around. I can see where it's very warm up near the ceiling. I can see it's pretty cool down near the bottom where the person is. I can float over this cut plane and get an exact temperature at any point in the model. So we can see it's 64.8. If we go over here, 65. So we're seeing a little bit of a delta between here, and then if I scoot that up closer to the mezzanine, we're seeing it at around 70, which is where we want it. So my guess is that the plaque diffusers on the ceiling, these up here, are not pushing enough air down closer to the floor. So if we flip this cut plane around, we can see here that it starts to really come to life. And I want to actually get some more quantitative data, right? I have a lot of great visual qualitative data, but let's get some quantitative data of exactly what that temperature is down in the occupied zone. So I can pull up this graph inside the points. We'll switch over. You can mix and match units as well, which is always great. And we can see that we do have a lot of variation in the occupied zone. So we need to change something. All right, so we're going to go back into Revit and make a design change. All your modeling happens in Revit. That's the or AutoCAD or MicroStation or Rhino, SolidWorks, again, any whatever CAD or BIM solution you're using. And we will actually switch over to a different design. So we'll go to this design 2, and what design 2 does is, let's go wireframe real quick so you can see that. With design 2, the second design, we've added some radiant panels right here in the mezzanine, and we've moved the diffusers, right? So instead of the 2 plaque diffusers up here, we've moved them down underneath the mezzanine, and we've added a linear slot diffuser over here to wash the glass and try to prevent so much of that air coming in. And also, this might help us with any condensation issues as well, which we can also study with simulation CFD. So once we're ready, it's a lazy engineer is a good engineer, right? I don't want to have to set this up again because it takes just a little bit of time. So we don't have to. We can go back into simulation CFD. We can right click on this first design and make a copy or a clone and create this design 2. We just give it a name, and then when we launch from Revit into simulation CFD with our launcher, we just push that design right into this copy. And we don't have to set anything up. All the boundary conditions are transferred over. All the materials are transferred over. All the mesh sizes are transferred over. All we have to do is click go. And once we run that, we can jump in here and look at some quick results, right? So now I can stack up all of the simulations that I've run in a common interface, and I can even set these up so that they rotate and pan and zoom at exactly the same as each other. I can link these views together, and now I have both of my designs. So imagine if you had 3 or 4 or 6 different designs that you were evaluating, all set up in a common interface. And in this case, I've put in what we call an isosurface, a cloud of air at 62 degrees. And I can see that in the original design on the left here, there's a pretty large cloud of 62-degree air along the floor, and on the right side, we've totally eliminated that using the radiant panels to warm the floor a little bit more and moving those plaque diffusers down to the bottom. So the other thing that I like to look at in this case is a plot that you remember I created that plot earlier in the occupied zone. We now have that plot for both designs. Let's switch our units back to Fahrenheit. There we go. And we can see that with design 1, this blue line, there's a lot of variation. Whereas with Design 2, with the updates, the modifications we've made, we have a nice, plus or minus half a degree compliant with ASHRAE 55, and so we know that this design will be successful. So maybe this gives us an opportunity to go back to the client and say, hey, here's why you need to move the ventilation system down into the mezzanine. Here's how much radiant panels will help you. Here's how much you can save on your ventilation costs year over year if you make a little bit more of an upfront investment in installing your MEP system. But there's just a broad array of reasons to run these types of scenarios and help your clients be more profitable, and in turn make your firm or your company more profitable as well.